ladies and gentlemen. 9-6 today's surface area and volume of spheres. So we're just going to talk about some vocab here for spheres. So I want you to write this down in that space, open space around all of it. All right, so first thing, let's just look for radius here. So which one of these definitions, plane that intersects, talks about plane, probably not, intersects the sphere in one point? That's a contender, because it does intersect the sphere in one point. Segment from the center to a point on the sphere. Ooh, that one is definitely a winner for radius. Segment from center to the point on the sphere. So go ahead and pause the video here so everybody can get that written down. And then come back. And let's go ahead and talk about this one. Intersects the sphere at one point. That's going to be our tangent. Tangent's only ever going to touch one place. Remember, it just brushes on the edge of the circle. Okay. Segment that contains any 2 points on the sphere. And then we have end points of the diameter. Chord that contains center. Those two seem very similar. Segment that connects any 2 points on a sphere, and then chord that contains the center. Well, when it talks about containing the center, that's definitely a diameter. So then that means chord has to be a segment that connects any 2 points on a sphere. So we have these last two definitions here, and they're going to go with this picture here where we have this plane that's running through. And so that is my great circle. Is the plane that intersects at the circle's center. And then we have poles, and the poles are the end points of the diameter on the great circle. So pause the video so you can get all of those written down. All right, hopefully you paused and got everything written down. Let's move on. We talked yesterday about why we won't have lateral areas. There's no technical sides or bases like tops and bottoms. So we just have surface area. So surface area is going to be 4 times pi r squared. Now pi r squared is the area formula for a circle. I have no idea how they came up with the formula that says 4 of the areas of the circle is equal to the surface area of the sphere. I'm not sure. We're just going to take that. All right, so a volume of a sphere. Now remember, volume of a pyramid yesterday was 1/3 of the area times the height. So we kind of see that 1/3 up here again, except for this time it's 4/3. And then it's pi times my radius cubed. These are definitely some funky formulas for these. They're not as intuitive as our other formulas. So don't forget, these two formulas you do need to write on your formula sheet that we will have that you can use on the test. Just a reminder, you can't write extra formulas on there or extra problems, example problems. If you do, you will lose that sheet to use on your test next week. All right, so, here we go. Volume of a sphere. So if you want to pause it here, you can go ahead and read this portion. This is just talking about the volume. It's putting things into a pyramid here. You see our pyramid up here, and the pyramid volume is 1/3 base times height, and in this case, the height is the radius. All right, so find the surface area of the sphere. Surface area formula is 4 pi times the radius squared. So this is really nice. You can just type that straight into your calculator. You don't need to find anything separately. All right, hopefully you have a moment to get that typed in. Check in with your neighbor. 452.4 centimeters squared. So spheres are nice because they only really have radius or diameter. They don't have height and slant height. We won't be using right triangles, I don't think, to find any of these. So here we have this red line. It's running all the way across. So that makes this a diameter of 22. So that makes my radius equal to 11. So when I just plug it in, it just asks us for surface area. So 4 times my radius squared. Go ahead and take a moment to type that into your calculator. Check it with your neighbor. Okay, so 1,520.5 feet squared. So those two, nice and short and sweet with that. This one says find the surface area if the circumference of the great circle is 5 pi. Remember, circumference is the measure all the way around my circle. It's like the perimeter of my circle. And so circumference is equal to diameter pi. Okay? So circumference is equal to diameter pi. So I'm going to set diameter pi equal to 5 pi. We have a pi on both sides, so we can go ahead and cancel that, and we end up with a diameter of 5. But for all of our formulas today, we want radius. So 2.5 is my radius. Now I'm finding the surface area. So I'm going to plug it in 4 times pi times my radius squared. All right. Once you kind of typed in, check it with your neighbors, table partner, 78.5 meters squared. All right. Hopefully this is feeling easy. You have lots and lots of practice in this whole unit about identifying things and plugging them into formulas. All right. Find the surface area of the sphere if the area of the great circle is approximately 130 inches squared. Okay, so this time I'm targeting the area, and remember area of a circle. Some of us need to remember that more than others. Area of a circle is pi r squared. So I'm going to set 130 equal to pi r squared. So I need to divide by pi first. And I'm actually going to just, don't type in your calculator yet. I'm just going to have you take a moment to look up. And it's r squared. So to get rid of that, I'm going to take the square root of each side. So r is the square root of 130 divided by pi. Then we don't really have to deal with any rounding, etc. like that until the very end of this. So the square root of 130 divided by pi, we got 6.4. So that is our radius. And we're going to go ahead and plug it into the surface area formula. 4 pi times my radius squared. And we want to put in that rounded 6.4 in there. Don't pull your previous answer with all the extra variables, or not variables, all the extra terms. This way we're more guaranteed that we're going to get to the same answer. All right, so we have one more before we add about hemisphere. So this one asks for the volume, and our great circle has a circumference of 8 pi, or 18 pi, excuse me. So circumference, remember, was diameter pi. So let's go ahead and put 18 pi is equal to diameter pi. I have a pi on both sides, they cancel. So my diameter is 18, that makes my radius 9. Volume is 4/3 pi times my radius cubed. 9 cubed. All right. Go ahead and find that. You should end up with a volume of 3,053.2 centimeters cubed. Remember, it's cubed because we're talking volume. All right, so let's go talk about hemisphere. Hemisphere is half of a sphere. So really, in surface area, we should be able to take 4 pi r squared and divide it by 2. So surface area, 4 divided by 2 gives me 2 pi r squared. But it's not totally done yet. Notice when we cut it in half, now we have created a base here, and that is just a circle. And so hemisphere has a base of a circle, and the base area would be pi r squared. Notice I have 2 pi r squared plus 1 pi r squared. So surface area is 3 pi r squared. volume, again, we're going to take half of the volume of a sphere. And so instead of dividing by 2, I'm just going to write it as 1/2 times 4/3 pi r cubed. And the reason why I wrote it as 1/2 times that instead of that divided by 2 is right here in these formulas. When you are dealing with fractions, 1/2 times 4/3, you just multiply straight across. So we get 4/6. And we can reduce that. 4/6 is going to reduce down to 2/3 pi r cubed. So similar to the first sphere, and a little bit different for the hemisphere. So I just realized there's no picture on the formula sheet for these two. So just go ahead and write these two next to the sphere box. All right, let's go ahead and utilize those formulas. Find the surface area of the hemisphere. They give us the radius. So all we have to do is plug it into the formula. Shocker, we have been doing this all unit long. 3 times pi times my radius, 2.8 cubed. Go ahead, I'll give you a moment to type it into your calculator. Check with your neighbor. All right, hopefully you got 73.9 centimeters cubed. Oh, not cubed, squared, because we're still talking surface area. And our next one is asking us to find the volume of the hemisphere. Again, they give us the radius. That's like the best information they could give us. So 2/3 pi times my radius, which is 6, cubed. All right, so hopefully you plug that into your calculator. Got a solution. Just check it with your neighbor. 452.4 meters cubed. All right, last problem. It's a word problem. Oh, I know, every girl. All right, the stone spheres of Costa Rica were made by forming granulite, I'm not sure, boulders into spheres. One of the stone spheres had a volume of about 113,097.34 inches cubed. What is the diameter of that stone sphere? So it's talking about volume of a whole sphere. So volume of a sphere was 4/3 pi radius cubed. So I want you to pause the video here and take a couple minutes and see if you can come up with how you can solve this on your own. Then, when you come back after a couple minutes, I would actually want you to take a few more minutes and talk to somebody else in class and see what they came up with. Okay, after a few minutes there, then I can have you come back to this video. So in about 5 minutes, you can come back to this video. So pause it here, guys. All right, hopefully you came back, you've tried it out, you have some type of ideas. So we're going to type in 113,097.34 equals 4/3 pi r cubed. Okay, so first step, set the volume that you're given equal to the volume formula. So I want to get radius by itself. So the first thing we're going to do is divide by 4/3 pi on each side so that that cancels. All right, go ahead and do that. You might want to put this part into parentheses, that might help. Okay, so when you do this left side here, you should get about 27,000, 0.0, blah, blah, blah. So we're just going to use it at about 27,000. And now we have our cubed. And so we need to get rid of that cube root. Well, squaring and square root are opposite of each other. So cubing and cube root are opposite of each other. So you're going to take the cube root. So this is not putting a 3 into your calculator and putting your square root. is there's put on your TI-84s. Go ahead and push the max button, and if you look down at number 4, that is a cube root. So go ahead and use that button on your calculator. Math number 4 gives you a cube root. So take the cube root of 27,000. And you should end up with approximately 30 inches for your radius. All right, so now what you're going to do is you're going to get handed out a maze sheet or a stations sheet, and then head out to the hallway. There's the stations out there. It's the maze ones where it doesn't matter what station you start on. It's going to direct you to a different one. Excuse me. And you should end up being able to go through all of the stations, and it brings you to the last station. Will bring you back to your first one. So go ahead and do that. And I would definitely take your formula sheet with you. You're going to see spheres and all sorts of prisms and some pyramids and cones, I believe, on there too. When you're done with that, you can turn it into the class bin. If you don't finish it in class today,